In this video, we're going to find the lines of best fit and also how to use them. So a line of best fit is a line on the scatter plot that's drawn so that it's as close as possible to all the data points. And this line will then be used to generalize the relationship between the independent and the dependent variables. So as you can see in here, the data points here kind of make the form of a linear form. So we can draw a line there then to show kind of the closest approximation or the average area. You can see some are a bit above, some data points are a bit above, some data points are a bit below, but this is the line that is as close as we can get to all of them. Now we can find the equation for this line by basically selecting two data points on this line. So we've selected here 13 and 20 and a second data point of 20 and 30. And then we can find it using the general equation for a line, y equals mx plus c, where m is equal to the gradient of the slope. Okay, so for an example, if we want to find the equation of the line, our first step is to find the slope. So we'll let x1, y1 be this first point here, and x2, y2 be this second point here. So that means your value of x1 is 13, your value of y1 is 20. Your value of x2 is 20 and your value of y2 is 30. And then we go and plug it into the gradient equation. So plugging it in, our y2 is 30, our y1 is 20, our x2 was 20, and our x1 was 13. So if we plug that right in, we end up with 10 over 7. All right, our step 2, we need to find c, or the constant here, by substituting one point into the equation. So we've already got our m. If we substitute, let's say, x1 into this x value and this y value, we'll be able to find the c because that will be our single variable that's left. So y equals mx plus c. We put our gradient in. We then substitute x1, y1 into the values. So we put our x1 into this x value and our y1 into this value. And then we just have to solve for c. So we bring the 10 times 13 over 7 over to the other side, so we end up subtracting it. We then create that 20, we make that 20 into a fraction over 7. We subtract the top two numbers and we end up with 10 over 7 as well. So then we substitute m and c into the standard equation for a line. So y equals, and then we get our 10 over 7 here for our m, x plus our 10 over 7 from our c right there. And our final step is just to replace this x and y, which is a very general one, with letters that are a bit more appropriate for our specific example. So in this case, the total cost we've said is c here, and our hours used up per month. We've replaced the x with an n. All right, so using the line of best fit, we can use it in several different ways. One, we can interpolate. So interpolation is predicting values within the range of given data values. So we've been given this range of data values here. We can predict any value that's along this line using either the scatter plot or the equation that we found. There's also extrapolation, which is predicting values that are outside of the range of data values. And that's kind of, if you just extend this line and keep extending this line, you can then predict values that are quite a ways off into either the future or the past of this data set. So an example, let's predict the monthly cost of using 17 hours per month. So if we use here 17 hours per month, we want to use 1 in the scatter plot. We just have to read it off, 17 hours per month. And it's really important to note we don't use this data point here. We don't really care about the data points anymore. We're just using the line of best fit. So our line of best fit is just right here. And you can see, okay, the total monthly cost just maybe slightly below this 26 here. So let's say 25.7, 25.8. Okay, we can also predict it by using the equation of the line. So the equation of the line that we found in the last question, c equals 10 over 7n plus 10 over 7. All right, so what we need to do is plug that 17 into the n because n is our x value here. So 10 over 7 times 17 plus 10 over 7. We multiply that 17 by the 10, so 170 plus 10, all of that over 7. We end up with 180 over 7, and we end up with a value which is 25.7, which is pretty much what we got on when we use the scatter plot. So both ways are very good ways of interpolating and also extrapolating values or predicting values on that line of fit. And that's the end of our lesson on the lines of best fit and how to use it.